In this presentation, we're going to look at permutations. Now, this is a second example. I've done a very similar example of this previously. As it is tricky stuff, I've done a second example. So let's look at our question. Suppose a four-letter code is to be made from the letters A, B, C, D, and E. Repetition is allowed, so we can have AAEC, for example, down the bottom, and the order of the letters in the code is significant. For example, the two examples we have down here, these correspond to entirely different outcomes, even though they're comprised of the same letters. The ordering is important. So let's move on. Let U be the set of all such codes. So every possible four-letter code you can make. Let V be the set of all codes beginning with a vowel. Let P be the set of all such codes that are palindromic. Now, a palindromic code is a string of letters which reads backwards as it does forwards. So the last letter and the first letter are the same. The second last letter and the second letter are the same. Now, because it's a five-letter code, it really doesn't matter what's in this. It really doesn't matter what's in here. But for argument's sake, if it was a six-letter code, we would have a middle pair of values. They would have to be the same. Okay. So I have four phases here that I'm representing with Roman numerals 1, 2, 3, and 4. So these are our phases. So this first phase tells me how many. This describes the selection of the first letter for the code, and we have 5 letters to choose from: A, B, C, D, and E. So we have 5 options there. So we're going to write 5 there. Because we're allowed repeat, we actually can pick the same letter as we picked in the first phase. We can pick that again, and we have 5 letters to choose from. So we have 5 here, and again we have all 5 letters to choose from. So we have 5 here and 5 here. So that is 5 by 5 by 5 by 5, or in other words, 5 to the power of 4, and that is equal to 625. So 625 elements in the set U. That's all possible codes. There are 625. Okay. So how many elements are there in the set V? V starts with a vowel. So let's look at our letters again. A, B, C, D, and E. We have 2 vowels, A and E. So let's start off. How many elements are there in the set V where the code has to start with a vowel? In the first instance, we only have 2 options for the first selection. So we can only pick A or E. So we've only got 2 options there. So for this first selection, we only have 2 options. After that, we have as many options as we had previously. We had 5 options for the second. We could pick any letter. 5 options for the third. We can pick any letter. And 5 options for the fourth. Again, we can pick any letter. So how many options do we have altogether? We have 250. How many elements are there in the set V? We have 250. There are 250 ways of making a code that starts with a vowel. This one's a bit more interesting. How many elements are there in the set P? In the set P, recall that it's palindromic, as in it reads the back to forth, the same backwards as it does forward. So, palindromic. Well, in the first instance, we pick the first letter. We can pick any 5 letters there for the first selection. So, A, B, C, D, and E. We can pick any one of those 5. So we have 5 options there. It's actually where this gets interesting as we go right down to the 4th option. Once we have picked once we have selected a letter for the first selection, the last selection automatically gets picked. It is whatever's been picked in the first selection must be picked here, and there is no other option. There is only one option. So that's why we have 1 here. How many elements are there? Okay, so how many select options do we have for the second selection? Well, again, we have 5. We could pick any of the 5 letters. But just as it was the case for the first selection and the last selection, we are now limited to one and only one option for the third selection. We must pick what we have picked for the second selection. So there's a matchup between these two. So we have 25 options in this case. How many options, how many elements are there in set P? There are 25. One more. How many elements are there in the sets V and P? So they're both in sets V and P. Well, we're going to use the two previous examples there to help us. It must be palindromic, so we have 2 letters, 2 options for the first selection. But automatically we are bound to pick one of those 2 letters, A and E, one of those 2 vowels, for the last selection. We can pick any of the 5 letters for the second selection, but we must use that selection again. We have no other options. So there's only one option for the third selection. So there are 10 elements in that are in both sets V and P. And that ends our presentation.